I'm making a class. What I'm going to do is demonstrate class rep and show how it uses stored compiler information. First of all, I'm going to fill in this record. Oops. Terminator. Okay, now class rep will get this it accesses the symbol table the compiler uses, and it will display. So it's kind of like a IDE debugger, but it's command line driven. Now it has the structures for pretty much everything. So now a similar feature is there's a metadata, which when you traverse the structure, you can access other data. This is a class declaration, and you can put an arbitrary metadata with a value, and then you can access it when you traverse the structure that the compiler built. So in this case, maybe you want a standard way to print fields, the string, or maybe you want default values. Now I guess in C++ you can already handle that, but in this this is not quite C++, but you can have default values or any kind of data. Up until the semicolon, it has name and then value pairs. Now one place it uses that is in forms. You can see here it if you do a form, then it can you can do the format string and tell the width and stuff. Now we're going to look at some features of the documents. Now the form we just looked at had a data widget. Now we're going to look at a text widget with a callback. Now we saw earlier how the LTFD and some other widgets are dynamic. Now every time it refreshes the screen, it calls a callback when it gets to this point, and the callback function supplies the text that it's displaying. Now a similar thing is called define string. Define load. Okay, let's say we have we're going to make a define string callback. So we Control L goes to the widget selection. We did a text widget, and the define string we want is test. So right here, whoops, why is it doing that? Okay, there it is. I don't know why I did that. Anyway, there's a text widget with the defined string, and the defined value is test. And oh, I know why. It's because it's not defined. That's why it's doing that. Now, if we do define test, okay, suddenly we have that word appear there. That's because it looked up the value in the compiler symbol table for test, and then it got that text. Now, define load, we can redefine it too. It's dynamic. That's how I show the age of the of LoseThos and the line count and stuff. With it's kind of like form letters. You can use define load is the same thing. Okay, so now we're going to look at some compiler features. First of all, the compiler can be invoked from inside code with exe putS or exe printf, and it returns the value of the expression. So, for example, what this does is mgetS will prompt the user for some text, and it'll use malloc, so you can never have a buffer overflow. And then it invokes a compiler on what they typed, and then it'll print out that many asterisks, carriage return line feed, and then it'll free it. So if we say 2 plus 3, oops, I didn't do 2 plus 3. We say 2 plus 3, we got 5 asterisks. Or if we say I64J equals 3, J times 2 plus 1, we got 7 asterisks. Or if we come up here, we say I64 L equals 4, then if we run it, we say L plus 3, we got 7 asterisks. So anyway, there's a preprocessor directive that will jump to the shell to the command line and compile some statements, and then it can put text into the stream being compiled. So normally this is for static binaries, but we're doing it on a just-in-time. So it prints hello, it prompts for some code, and then it puts the code into the stream being compiled. And so if we say what is goodbye, and we got hello, goodbye, and we didn't have a carriage return line feed. Anyway, now it compiles statement by statement and executes. When it hits a function, it waits till it gets to the end, and then you invoke the function. So this is perfectly valid right here. You can define U8 is a character, and so we're defining an array of characters. It looks like it's variable length, but it evaluates it at the time it's compiled. It evaluates I at the time it's compiled. So that's how that works. Now, some tricks that LoseThos uses is it converts variables to constants, which makes them more efficient when the compiler runs. So it's really easy to convert a variable to a constant. Now we're going to do a color change, color red. Now the compiler is invoked even on is invoked on document commands. So if I say red +1 and switch back, we toggled to plain text. Now we go back to regular mode, and now it's purple. That's red +1. Or if we say I64, let's say LL equals brown. Then if we come up here and if we say LL, now it's brown. So the compiler's invoked all over the place. It doesn't have much overhead starting up, so it's used all over the place. Now, one thing I wanted to show is scoping. The compiler this is the Adam task. He's the father of all tasks. You don't type on his window. Tasks inherit the symbols of parents. So if we make a symbol, this will execute some code in Adams by Adam. So we say Adam, let's say JK equals 6. We don't see anything. Now we have a variable that's system-wide. Anyway, a regular variable is just like a local variable, local environment variable, but that's like an environment variable for Adam, and it's really elegant how startup works. All it does is it does like an autoexec.bat. It starts up. When it starts up, it starts executing this code, and these files load symbols and code into Adam's tables, and then at the end of startup, it spawns some user windows, and those inherit all the symbols in Adam's tables. So it's really elegant.